Okay.
So, is a statistical model applicable on large data sets with a big number of input variables?
Yeah, I mean, there, of course, you can say one thing that this, I mean, there's these days the talk about the AI and machine learning, and to some extent, there are a little bit different, I mean, approaches to this, because there are certainly techniques which can, let's say, but still they are using these techniques in an automated way such that they find models without a model or having to do too much in terms of interacting with the model and defining the model. So, I mean, you can have many techniques, regression trees, we work with them, and we work with there's another called the lasso regression and rich regression, that basically you can use thousands of input variables and it will boil it down easily for you to the 10 most important variables. But it depends on the application, and if you want to learn how the system works and really to find to get insights, or you just want a model for prediction, then you should definitely use different techniques. Yeah, but of course they work with a large number of input variables, but as the model gets more complicated, it gets more complicated to estimate parameters. But there are many different techniques in yeah. So depending on the application, that's what you should choose the right technique. I mean, there's a lot to say about aggregating to different yeah, let's say time resolutions or resampling, because basically if you take, let's say you go from minutely values to hourly values and you just take averages every hour, then you know that you're removing a lot of information. So depending on if you're interested in this information, then if you are interested, you shouldn't do it. But if you're not, then it makes good sense to average to a lower sampling rate, basically. So, and because that makes the model simpler, you don't need as complicated a model for the hourly data compared to the model you need for the minutely data, most likely. So, but you cannot come up with one answer to that question. It depends on the data you have at hand, and especially again the application. What do you want to get out of the modeling? What results? The R scripts that I showed just was with the example is on the website, but I can also it's not really interesting. But the examples, the R scripts and the data is on the website.
Okay.
The models work on all type of data sampled from dynamical systems, so it's just generalized. It's not. It can be used for finance. It can be used for all kind of applications. But of course, then now the focus is on buildings and heat and energy and temperature. So and there it works very nice because we also know how the physics more or less should work, and that's what we can exploit in these gray box models. Temperature data. I answered that question. I think it was question 2 more or less. So.
Yeah. And last one, would you have a bigger shorted to the estimate parameter which is less to the
Yes, exactly. That's what the gray box models. There, the parameters are actually, I mean, directly linked to the physics. So it's a capacity, heat capacity, or it's a thermal resistance. The value of those parameters can be directly physically interpreted and related to the building. Exactly. So yes, that's the whole point of these, or that's an important point of these gray box models. All right, I think that kind of concludes. I hope you got something out of it. I know it was very fast and it was really flying with the play. I could use twice as much time and explain more in details, and we could have had questions during the presentation. But it works, I hope, and I hope that you kind of see that if you it will, of course, you have to use some time to get the knowledge, but this is really strong, and I mean, these are the techniques that have been used for many years in many applications. So it's really good stuff if you invest the time in working with it.